Hello, I'm Kyle. I'm the technical content developer at Maple Systems. Welcome to the Maple Systems video training series. In this video, I'll be going over how to program the different timer instructions in MapleLogic and simulating each timer online connected to a PLC ES1616P Maple Modular PLC. Please keep in mind that you can also use any of the three Maple Micro PLCs. There are 5 kinds of timers in MapleLogic: a timer on delay, a timer off delay, a retentive on timer, a retentive off timer, and a non-retentive off timer. Before I get started, a timer is a PLC instruction measuring the amount of time elapsed following an event. They are PLC instructions that can be used to delay input and output signals in the PLC program. So in my program, you can see I have a T on timer on delay, a T off timer off delay, a TMR retentive on timer, TMON retentive off timer, and a TRTG non-retentive off timer. And you can see in each instruction, I have different variables used in my logic. So over on the right, I have my variable editor. So I'll just go over each one. So for the enable button for each timer instruction, I'm using an X bit. So for the T on, I'm using X00. For T off, I'm using X02. For TMR, I'm using X04. For TMON, I'm using X06. And for TRTG, I'm using X08. I'm also using reset bits, which is also an X bit. And for T on, X01, T off, X03, TMR, X05, TMON, X07, and TRTG, X09. And then for the actual timer bit, I'm using T register. T stands for timer. So T on is T10, T20 is T off, T30 is TMR, T40 is TMON, and T50 is TRTG. Then also I am using Y bits for the output of the instruction. And that's Y01 is the T on output, Y02 is T off, Y03 is TMR, Y04 is TMON, and Y05 is TRTG. So also for each instruction, there is an application instruction that I created within the logic. So you have the enable bit going to a application instruction. So if you double click on this, I have T on first in the instruction, and then the timer bit I'm using, which is T10, and then 50 is the preset value. Now, probably wondering why it says 50, and this is actually 5 seconds, and I'll explain that in a little bit, why we enter 50 here for 5 seconds. And so each one of these has these application instructions, so you can see here, as well as a reset instruction from the reset bit, and reset is RST, and then you put the timer bit next to the RST. I want to go over what this 50 means in the preset value. So if you go over to PLC parameter and double click under the basic tab, here are your timer settings. So what this is saying is that 100 milliseconds is between registers T00, so timer 00 to T127. Now you can set this to whatever value you want in the registers, but I have it set to 127, and 10 milliseconds between T128 to T511. So what this is saying, if I have an application instruction, let's go back to the instruction here. So if I have this here, so I have TON, T10, and 50. So what this is saying, that between registers T00 and T127, which is what it was set in the parameters, 50 means that 5,000 milliseconds equals 5 seconds. If this was set between T128 and T511, 50 would mean that 5,000 milliseconds equals 0.5 seconds. It would either be 5 seconds or 0.5 seconds, and if it was 100, it would mean either 10 seconds or 1 second. Hopefully that explains that a little better, understanding that. So because I'm using register T10, that's between T00 and T127, 50 is going to be 5 seconds here. And now we're online, and you can see that in the indication here, PLC is okay. We are in run mode, and I have forced IO X input here. And to change that, click here, and do force input X enable, hit download. So now I can enable the X bits in my timer instructions. So the timer on delay is going to count up to the preset value. So if X00 is on, the instruction counts up to 5 seconds because we have a preset value of 50, which is 5,000 milliseconds or 5 seconds. And when the accumulated value, which is right here, reaches 5 seconds, T10 and Y01 will turn on. So when it hits that preset value, the output will turn on. And then also, to reset it, you would enable X01 and it'll reset it back to 0. And then also, if it's disabled when it's counting up to 5 seconds, if it's disabled here, it will reset back to 0. So I'm going to simulate it. So turn on X00, and it's going to count to 5 seconds. When it gets to 5 seconds, the output will turn on, and then I'll do a reset. Resets back to 0. I'll disable it when it's counting. So it's counting up and disable. It'll reset back to 0. So for the T off, when I turn on X02, it's going to set the cumulative value to the preset value. So you'll see 50 here, and it's also going to turn on T20 and Y02, which is the output. And when I disable this, it's going to count down from 5 seconds to 0 seconds. When it hits 0 seconds, it's going to turn off T20 and Y02, which is the output. And if I hit the reset button while it's counting, it will reset back to 0. So let's do that. Let's turn on X02. It's going to set at the preset value and turn on T20 and Y02. And then I'll turn it off. It's going to count down from 5 seconds to 0 seconds. When it gets to 0, it turns off. Now, if I hit the reset button while it's in a count, so let me reset this back to the preset value and then turn off to start the count. And while it's in the count, if I hit the reset button, it'll reset back to 0. Also, for the T off timer off delay, when you enable it, it'll set it to the preset value. And if I disable it, it will start a count from 5 seconds to 0 seconds. But if I enable it again while it's counting, it'll reset to the preset value. So for the TMR, the retentive on timer, the difference between a retentive on timer and a T-on timer, so a regular on timer, when you enable this X04, it will do the same thing as a T-on. It will count up to 10 seconds because the preset value is set to 100. But if you disable it, it will hold that accumulated value rather than reset to 0. If I enable this, it's counting up to 10 seconds. If I disable it, it holds that accumulated value at around 5 seconds. And if I enable it again, it'll continue the count up to 10 seconds, and then when it hits 10 seconds, it will turn on the output. The reset button is the same. If you hit the reset button, it will reset to 0. That is reset to 0, but also if you have the timer going, if the reset button is pressed, it'll reset to 0. But if the X bit is disabled during a count, it'll freeze on that accumulated value, and then if you enable the X04 bit again, it will continue the count to 10 seconds. For the TMON, the retentive off timer, the difference between a TMON, retentive off timer, and a T off is if you disable it while it's in a count, it'll keep counting for the retentive off timer, and for the T off timer, it'll just reset back to that preset value. Also, for the retentive off timer, when you enable the X06 bit, it'll start the count right away. So let's enable that. And then if I disable it, it still continues to count down to 0. And when it hits 0, the output turns off. Now, if I enable X06 and then hit reset, it'll just reset to 0. And for the TRTG, the non-retentive off timer, the difference between a non-retentive off timer and the retentive off timer is if you disable the non-retentive, it will keep counting, but if you enable the X08 again while it's counting, it'll reset the count. Rather than for the retentive off timer, if you enable the count and then disable it, it'll just keep counting. Even if you were to enable it during a count, it'll keep counting down to 0. So show that. So you enable it, starts to count, disable it, and then enable again, it'll reset the count. Now if you were to enable this and then hit the reset button, it'll reset to 0. So now I've gone over all the timer instructions in MapleLogic, so this is all I'll be covering today. To get more information, you can visit the How to Program Timers tutorial page on the Maple Systems website. I hope you enjoyed this video, and thank you for watching.